Okay, let's write an augmented matrix. Now, I am going to put it in X, Y, Z, W. And the actual order that you put it in doesn't really matter as long as when you go to interpret it, you interpret it in the same order. For instance, this last one we did, we put X, Y, Z. Of course, it makes sense to do that order, but you could have put Z, Y, X as long as when you read the answer, you read it in the same order. Okay? So, on this one, I'm going to have 2, 5, 1, 3, 0. The next one, since there is no X, that is a 0. 2, negative 4, 6, 0. 2, 17, negative 23, 40, 0. Can you go ahead and put that in our REF for me? So say 3 by 5 in this case. Something on your calculator? Oh, imagine that. Sticky baby. For calculator, can you not hear it? There's sticky buttons.
Is that Nicole's over there?
Yeah.
That was terrible.
Okay. What will I get in the first row? 1, 0. 5, 1. What? I don't know. I'm just reading off what Jacob told me. What do I get in the first row?
1, 0, 5.5.
5.5.
1, 0, 5. 5.5.
0, 0.
As in 1/2.
Yeah.
Thank you. What else?
No, 5 halves.
11 over
Okay.
It's right there. I had it.
Thank you.
5.5.
Why are you giving me a decimal?
Because it gets
It's been
over
beat in this class if you start giving me decimals.
Just kidding, that's not it. 11 over 2.
Oh, okay. Can't even get it right.
Back it right?
No.
What'd you say?
Then we have
Someone I've never
0.
done it.
No.
Is that correct? Yes?
C.
Yes.
Okay. Now let's look at what this says. The first row really says X plus 11 halves Z is 0. Does everyone agree that's what the first row says?
Yes.
Second row says Y plus negative 2Z equals 0. The third row says W equals 0. They don't all equal 0.
But they could.
Well, yeah, that's usually true of most systems, but yeah.
I checked and I made sure that all of them was smart.
I'll have to look at it. I'll have to look at what you're putting in wrong. Just probably you missed a negative or something. But I need to get this because this is not an answer, is it?
No.
It actually is an answer. It's just not a answer. What do I mean by that? It's not one answer.
Do you get
It's
Z by 2?
infinitely many.
It's infinite.
Okay. It's infinitely many. I have nothing but true statements here, correct? But here's how you can kind of tell if you're going to have an infinitely many. See this column does not have a leading one? Usually, if you have a column that's missing a leading one, you have infinitely many solutions. That's exactly what we're going to do. Which column here is missing the leading one? What variable is that? Z. So I'm going to let Z be T. What I'm doing is introducing a parameter, is what it's called. Last year you should have touched upon something called parametric equations. We start those in calculus.
We almost had
Chapter
that. We
1
almost got there.
Okay. But now if Z is T, then over here this statement is X plus 11 halves, T is 0, correct? This first statement, all I did was rewrite the Z with the T. Then X equals negative 11 halves t. I'm going to do the same for the second statement. Y plus negative 2z, or it's now negative 2t. So y equals 2t, and w is still 0. But now you see how all variables, z, y, x, are all in terms of t? Yes? They all depend on the same thing, which is what a parametric equation is. Okay? So I'm going to write this as a point. The point, xyz, is negative 11 halves t, 2t, t, and w is always 0. T is any real number. And I'm going to write above it infinitely many of the form. There we go. Because what this is saying, pick any number.
2, 1.
Or 7.
Seven.
If I plug in 7, it's a solution. If I plug in 12, solution. If I plug in square root of 2, it's a solution. So it's not saying everything works, it's only of this form works. Yes?
Yeah.
Okay, so that's our infinitely many form. I had to get them all in terms of t.